Okay, Austin Meeks and Russell Martin, we have section 0.4 inverse trigonometry functions.
f of x has domain x and range y. The inverse of f of x has domain y and range x, making them opposites. The inverse of f of x can also be made into g of x. In this example, f of x equals x to the third plus 1. G of x equals the cube root of x minus 1. This shows that the inverse can be reversed by the original function when f of x is substituted for x, and it undoes the entire equation, making it x.
Graphs of inverse functions. So let's say we have f of x equals 2x, so the inverse of f of x would equal 1 half x. Graphing these two functions, we have y equals 2x in red and y equals 1 half x in green. Notice these two lines are reflections over the line y equals x. So if you were to take a more complex equation like f of x equals x cubed and its inverse, which is x to the 1/3 power, and graph that, you would notice there are also reflections over the line y equals x. This makes sense because previously we switched the variables y and x, and now we switch the coordinates y and x. There is a certain type of function that needs addressing, which is when x is at an even power. Say we use the graph to find the inverse. We graph x squared and then reflect it over the line y equals x. This doesn't work because the new function in green doesn't pass the vertical line test. Instead, we must limit the domain of x to be greater than 0. This gives us only half of the parabola, but then once reflected, gives us a function, the square root of x.
The inverse of sine, cosine, tangent, and secant are known as the arcsine, arccosine, arctangent, and arcsecant. When looking at these, the domain and range will be swapped when comparing to the originals, meaning the x and y values are the opposites. The inverse of sine has -1, 1 domain, when the sine has a range of -1, 1, and so goes for all the others. This pattern can also be seen when looking at the graphs, seeing as how the domain and range are swapped, meaning the x and y axes are swapped. Cosine and inverse cosine also share this pattern because their x and y are also switched. Tangent and inverse tangent also share this similarity when looking at the graphs. Secant and inverse secant also relate because you can see that if you continued the inverse secant graph, it would look very similar to secant, just flipped.
We all know SOHCAHTOA, where the sine of theta equals opposite over hypotenuse, the cosine of theta equals adjacent over hypotenuse, and the tangent of theta equals opposite over adjacent. So now we have a right triangle with an unknown angle theta and leg lengths of 5 and 11. We can find the angle by taking the tangent of theta and then using the inverse tangent function to find theta, which equals 24.44 degrees.